Hi everyone, my name is Ilya. I am blockchain architect at NEAL Foundation. At NEAL Foundation we are working on ZK rollup, but sharded one. So we work a lot about cross-chain scalability issues, because formally saying execution sharding is close to the idea of cross-chain interoperability. Sorry? Oh, sorry. I apologize. Yeah, so execution sharding is close to the idea of cross-chain native interoperability, so that's why we explored these questions a lot. And first of all, let's state one problem, that what we observed, that 80% of all transactions on the Ethereum network is somehow addressed to ERC20 contracts. So, and that's quite obvious problem, because if you imagine interaction with the single contract, it creates a bottleneck for your network. Second, quite important thing to mention, that we are in the era of interoperability and horizontal scaling of our solution. Louder? Even more louder? So you can hear me? Closer, like this? Yes. Okay, hopefully. I apologize, yeah. So yes, and interoperability and horizontal is becoming a key pillar in our current development of L2s. And also, let's notice one important thing, that scaling solutions lose effectiveness if some of the on-chain logic becomes a bottleneck. So, okay, let's once again recap the idea of ERC20. As we know, actually it's based like a simple registry, so we have just transfer, approve, balance, and mapping of your balances. Quite simple logic, probably majority of you quite familiar with this. And interaction is very simple. You send transaction to the contract, and the contract inside itself just changing the balances from, like, for example, if you transfer from your account to my account, it just deducts from my account and adjusts your account. But what is the actual problem is that we have two options for the cross-chain scalability of your tokens. First of all, you have a synchronous example. If ERC20 is deployed on one chain, and all the other chains to interact with this money, then the transactions to this single chain. What happens? Right, you have actually a overloaded network, and the rest of them are just stealing. In case of a synchronous access that we all quite familiar with at the moment, is that in case of different ERC20 deployed on different chains, you have problems of synchronization, bridging, proving, and still it's extremely inconvenience to build cross-compatible applications. And yeah, what are the actually problems? First of all, failure handling, because if something happens wrong on the destination shard or destination chain, the handling the errors is a big problem. Double spending and security issues, of course, because more complex cross-chain logic you have, more complex you have logic for your registry management. Complicated cross-chain synchronization, what I mentioned in previous slide, and you still don't solve the problem. Imagine the ERC20 for like Solana chain. Like, you cannot so simply scale it even parallel, because you access same smart contract and same database. That creates a problem of not even scaling cross-chain, but also scaling it, like making it parallel. So what we suggest to do? So there is one interesting concept called enshrined tokens. Probably some of you already heard this somehow, but enshrined tokens is the idea that's similar to cash. Imagine that ERC20 is like your bank account. So all of you have them, let's say, American bank account, and you have a single registry where your ID and multiple currencies are written. Enshrined token inherits the idea of cash. Each of you has US dollars in your pocket, right? And but again, we don't have a single registry where these dollars are written. So we only know the overall supply, but we don't have a single registry that knows every balance of the cash. So the enshrined token inherits this idea. So how it works? First of all, we have a single contract that can mint and burn the tokens. Yeah, quite simple one, just to prevent over minting. Also, currency ID is actually just the address of this contract. Also very simple idea, because actually US dollars has a ticker. In smart contracts, we have actually addresses. And only owner can mint and build the tokens, and only smart contracts receive and send token it holds. So we cannot send you actually minus balance. So let's see how it looks like. We have a smart contract, and actually the tokens and trade tokens are like a balances on this smart contract. And this smart contract can be whatever you want. Like that can be your smart wallet on chain, and you have balance in native currency, and tokens. For example, the first token that is 0x27, that's USDC. And it's written directly on your smart contract. And now, transferring and minting looks very simple. First of all, we just mint the currency and deposit directly to your smart account. And that's it. You have a registry of this balance on your smart account. At the same time, transferring from one smart account to another smart account as well, very simple, because what I need is to deduct from my contract the balance and actually send a message to adjust on your. That is actually done using just simple precompile smart contract logic. But let's see a bit complex example that actually reveals the whole idea and the whole pipeline. So you have a user who is actually minting 100 tokens on some USDC contract. This contract deposited to user wallet, and you have this balance that is 100 now. I, as a user, now want to deposit on different chain, and what I create is just a transaction to say like, okay, please deposit it from my wallet to this wallet, and what we have, my tokens becomes 40 on the destination chain 60. And noted that USDC contract has no any idea about, okay, how many contracts I have or this wallet have. The only it knows is what is total supply, and actually that's it. So, and actually quickly about bonuses of this system. First of all, let's start from the minuses, because they are very few. First of all, extra protocol logic. That can be a problem, because the protocol requires some precompile, stateless, simple, but still precompile to handle the logic of transferring and trade tokens. Also, we have a bit harder compatibility between ERC20. For example, approvals are not very easy in this system, or for example, account blocks. So you cannot so easily block the account in this system. At the same time, you have account abstraction friendly system. That means that the only way to drain your money is just to break your own wallet, your own account, and not ERC20. So you don't delegate this to other contracts. You have direct transfers. So I don't interact with some other contract to deposit to your account or to your wallet some amount of money. I do it just directly. So you don't have multiple contracts, because now we have only a single contract that we have mint and burn. You don't have a bottleneck, because actually there is no a single contract that we interact with. So very easy one. And easy refunds and error handling, because now refund is just sending your money back. We don't even interact with any other contracts. That's create very simple error handling. And please, if you want to see how this enshrined token works and how this cross-chain system can operate, you can check our IMM decks. And yeah, thank you for your attention.